Hey guys, today we're going to take a look at linear and nonlinear relations. So first of all, what a linear relation is a relationship in which two variables change together by a constant amount. Okay, so as one variable increases by 1, the second variable will increase by a set amount each time. Okay? So often we'll use a line of best fit in this case. This is a straight line that describes the relationship between two variables in a scatter plot. Alternatively, we can use what we call a curve of best fit. And this is exactly the same thing, except that it is a curve. So it is, hold on, let's try and see if I can get this a little neater than the last couple. So this is a curve. It's not much neater. A curve that describes that, oh no, it's messier, describes the relationship between two variables. Between two variables. Well, I'll put that on the next line. Oh, it turned red. That's okay. Variables. I don't know why. I must have hit it. Okay, in a scatter plot. In a scatter plot. I think it looks nice like that. I think I might just start changing to a different color every time. Anyway, so to begin with, a linear relation is not necessarily a good fit in all cases. We do a scatter plot, and sometimes we'll use a line of best fit, and it's not necessarily the best thing to do. So we've got 3 examples here of when it is not a good fit. So this one right here, you can see the line is going pretty close to all of the points. The problem here is there's only 4 points, so there's not enough data. Whoops, that's not how you spell that. So not enough data. Like we can make, when you've only got 4 points like this, you could do anything to make it, you know, sort of look like it fits the trend. I mean, you could just, yeah, so you really need to have more data than that. So this next one here, we got our line of best fit, and there's certainly enough data here, but the bottom line is that this would be better with a curve. If you look, the data kind of more goes like that. So in this case, probably a curve of best fit would be better. It's what we call nonlinear here. Okay, so curve and nonlinear obviously just means it is not linear. Is better. This is nonlinear. Okay, and then finally, this one here, this last one, this is a case where often you'll see people do things like this where you'll draw a line of best fit through this data. And the bottom line is that the data doesn't really have any correlation whatsoever. It's kind of random. And so using a line of best fit, like look how far out it goes. Like it's all over the place. Okay, so there's no correlation here. There just is no correlation. It's random data. Okay. And so using a linear way to represent that is quite misleading. Okay. All right. So next one here. We're going to do a little example here. So a super cool lizard lives in the magical country of China. Data shows that this lizard keeps its body temperature close to its surroundings. So we've got a graph here of its surrounding temperature and the lizard's temperature. Now, first of all, you have to identify which one's the x and which one's the y. The x being your independent variable. So the surrounding temperature is not affected by the lizard. That's ridiculous. So we're going to call that x. We're going to call that one the independent variable. And then the lizard's temperature changes depending on the surrounding temperature. So that will be our dependent variable. Okay? All right, so the first thing we're going to do is we're going to graph this, and I'm going to use some, I'm going to use some magic here. And there we go. We've got all our data plotted. Oops, I forgot to do some titles. And there we go. So, first of all, how are the variables related? Okay. So basically what this is showing us is that as the surrounding temperature increases, the lizard's body temperature increases. So as surrounding increases, okay, the lizard body temp increases. All right, so the next question, or the next thing, is to draw a curve of best fit. So this is where, before we kind of did, we would have drawn maybe a line of best fit, and we would have kind of gone like that. That doesn't really fit the data very well. So what we're going to do is we're going to use a curve of best fit. And I'm going to do something that's going to look kind of like that, basically. Okay, so there we go. So you can see how the data is kind of a little curved. I didn't quite get it exact. I'm actually going to try again, see if I can do a little bit better. The advantage of being able to erase it like that. But let's go kind of like that. I think it goes a little lower. Yeah, that's pretty good. It's not perfect. Doesn't have to be perfect. Okay, that's okay. We're just eyeballing it. So we're going to estimate the lizard's temperature if the surrounding is 26. So what you're going to do is you're going to go up here. You're going to say, okay, the surrounding temperature is 26 right there. So we go up there to the line and we say, oh, it's right there. So we go over and we see that it is at 28.5, halfway through, or between 28 and 29. So it's going to be 28.5 degrees Celsius. So what is this called? Well, this is an example of what we called before interpolation. Okay, and the reason it's interpolation is because it falls right in the middle of our data set. We have data starting at a little bit less than 25, and it goes up to a little over 30. So it lies in that interval, and so that's called interpolation. The next one, which I'm actually going to make a change to, I'm going to change that to a 24. 24 degrees, because this is something that people often don't get or make mistakes on. So interpolation, whoops, what did I just do? Oh, redo, there we go, okay, sorry. Okay. So we're going to estimate at 24. So 24 is right, I'm going to switch to red, right here, okay, there's 24. So we go up, and it's going to be about, it's hard to see without what I've got here, but we can say 26 or 26.5. I guess we'll say 26.5 right there, okay? Okay, so we're going to say 26.5 degrees based on our graph, okay? So this one's called extrapolation, okay? And extrapolation means that it doesn't lie within our data set, okay? This one was before our data set, and the reason I wanted to change to the 24 instead of the 34, or whatever it had before, 35 or something, okay? 35 comes after the data. You're seeing what it said after it, and it's the same thing. It's extrapolation either way. It doesn't fall within the data, so this is extrapolation. And that is it. So, there we have it. Until next time, go Sabres.